Today we work with Neurosynth, and we will download some activation map from Neurosynth and create some region of interest to be used in marsbar for an ROI analysis. So Neurosynth is this website that contains a lot of meta-analysis on fMRI data. You can, if you go to meta-analysis and terms, you can basically write whatever term you want in this search box, which can be attention, language, working memory, so terms that that refer to cognitive functions, or you can also use a term that refer to anatomic, like a functional anatomical cortex, as for example visual cortex or motor cortex and so on. And what the website will do, it will show you activation map for that terms that you can download on your computer, so you can use it for analysis. And for example, you can use it to see how in your specific sample the activity for language, for working memory is on the base of your task. In my case, I want to download working memory. So working memory is the word that I am interested in. So if I click on working memory, I am going to see this activation map, and we can say that it looks pretty sensible. It looks basically to correspond with to the classical working memory area. So frontoparietal activity, basically some insula, some presemi, and also lateral prefrontal cortex, and so on. And here there are different options. I can change the threshold if I want a more conservative activity, and I can also download this map. You can download, you have two options of downloading: the working memory and the uniformity test. So sorry, the association test and the uniformity test. The difference between these two will be difference in terms of statistical the statistical way in which these two maps are calculated, and usually the association test is more conservative than the uniformity test. For any other information about the distinction between these two, I will recommend you to read this area of the website, because it may be useful to make a choice. Anyway, I am going to download the association test because it's the more conservative, and then I'll go on MATLAB. I go on MATLAB and I open SPM, and the first step will be using this toolbox of SPM, which is called ImCalc. Opening ImCalc, so ImCalc basically is a toolbox that allows to do different transformation on image, and the transformation that I am interested today is basically to create binarized map from the thresholded map that I downloaded from Neurosynth. In this way, I will have a mask, which a mask that an image mask that will be formed by either 0, 1, and the 1 the voxel that are contained in the region that are active during the working memory will be equal to 1, and the other region that are not active will be equal to 0. So to do so, I will use the map that I downloaded from Neurosynth. I put in this folder before, and you can put it in every folder you like on your computer. So just upload it. The file name can be WM, and as output, so where I want ImCalc to save my binarized mask will be on the same folder, and as expression I'll use E1 more than 0. So every voxel that is more than 0 will become equal to 1. So it will become basically part of this mask. So if I run the batch, you can easily display this on SPM. So for example here, but it's not really understandable what it is, because there is no brain anymore. But you can see there are this cluster, and this cluster correspond to the activation that we saw before. To give you a better idea about how they look, I will work on MRI Crow. So if I open my